Multiples, a number that can be divided by another number with no remainders. Well, what does this mean? Well, if we take a 9 and we divide it by a 2, the answer is going to be 4.5. Clearly, there's a remainder, so this breaks our definition completely. 9 cannot be a multiple of 2 because of this very reason. So, there was actually no point of me doing this. Let's take, for example, prove that 35 is a multiple of 5. Okay, well, according to our definition, a number that can be divided by another number with no remainders. 35 divided by 5. I'm just following the definition. 35 divided by 5 is 7. 7 has no remainders. No remainders. Therefore, we can conclude that 35 is a multiple of 5. How do you find out multiples? Well, you just take a random number. Just take any number. Let's take the number 4. Take the number 4, multiply it by 1. 4 multiplied by 1 will give us 4. 4 multiplied by 2 will give us 8. 4 multiplied by 3 will give us 12. Let's just do one more. One more for good luck. 4 multiplied by 4 will give us 16. The list can go on. We can go on. We can go to 5, 6, 7, 8, 9, 10. The fact of the matter is that all of these numbers, 4, 8, 12, 16, are considered multiples of 4. Yes, itself. 4 itself is considered a multiple of itself. Don't forget that number. That's a very important number. Well, multiples, the opposite of multiples would be factors. That's the point of this video, multiples and factors. So, a factor is a number or numbers that we can multiply together to get another number. And when we were talking about multiples, we were talking about individual numbers. So, for example, 12 is a multiple of 4. But with factors, we don't really talk about them as individual numbers. We talk about them as factor pairs. Let's take, for example, the number 15. We have to list the factors of 15. What are the factors of 15? We list it as pairings, numbers that can be multiplied together to get that specific number. Well, if I multiply 1 by 15, I get 15. What else? 2. No, 2 does not work. 3. Yes, 3 definitely does work. 3 multiplied by 5 will get me to 15. Can you see how we name them as pairs and not individual numbers? If I wanted to name them as individual numbers, I can say that the factors of 15 are going to be 1, 3, 5, and 15 itself. Don't forget about these two. These two are still considered factors. Factors of a number will always be 1 and itself. And in the middle, well, that's for you to decipher. Okay, let's see. In this example, it says, name the factors of 20. It's the exact same process that we just did above. The factors of 20, well, start with 1. 1 multiplied by 20, 1 and itself, that takes care of that. Does 2 go into 20? Yes, it does. Yes, it does. 2 multiplied by 10. 2 multiplied by 10. Does 3 go into 20? No, it doesn't. Does 4? Yes, 4 works. 4 works. Does 5 work? Whoa. Hold up. See this? When you get this repetition, when you get this repeated process, stop. That means that you have covered all of your bases. That means that even when you're doing the bigger numbers, and you see this repetition take place, it means that you've covered every single factor out there. So the factors of 20 can be listed as follows: 1, 2, 4, 5, 10, and 20 itself. Can you see that 20 and 1 are still considered factors of 20? Please don't forget about those ones. At the end of the day, the middle numbers, well, that's up to the number itself, but 1 and 20, just don't forget about those numbers. To conclude, multiples, these are generally the bigger boys. These are the bigger numbers. If you take 4, for example, all of its multiples are bigger than itself. Factors, these are usually the smaller boys. These are the smaller numbers. If you take the factors of 20, 5 is smaller, 4 is smaller. You kind of can see a pattern here. Okay, cool.